Galaxies shouldn't exist. Based on everything we know, they should fly apart. And yet there is something that seems to hold it all together, and we still don't know what it is. So it's time to put your mind on the matter of dark matter. Dark matter is the biggest mystery in the universe. It seems to be unable to reflect light, emit light, and it doesn't interact with anything we can detect, and yet it still has mass, and we can use this to prove its existence. Scientists have theories, real strange ones, from invisible particles that can only interact via gravity and the weak nuclear force, ghost-like matter, or even ancient black holes. But nothing is confirmed. So here are 5 pieces of evidence to prove that dark matter exists. Firstly, galaxies move way too quickly. Vera Rubin, an American astronomer in 1970, discovered that stars on the outer edge of galaxies moved far too quickly than what should have been possible without being flung into intergalactic space. They came to the realization that there must have been some missing matter which was holding it all in place. This is probably the most famous piece of evidence for dark matter. Next, gravitational lensing. Even if we can't see dark matter, we can still see the effects of it. According to Einstein's general relativity, mass curves spacetime. If you need an explanation on how this occurs, check out this video. So, if light from a distant object were to come close to a massive object, its path would get deflected. This would cause its image to become larger or distorted, or even there would be multiple images of that same object. So if we were able to see light getting distorted in such a way where there was no visible mass, that's a clear indication of dark matter, and we have seen this. In 2006, scientists observed the bullet cluster and noticed something strange. They noticed, using the NASA's Chandra Observatory, some hot X-ray emitting gas being distributed slightly differently to some other mass. In this image is shown as pink for this normal matter gas and blue for this other stuff. Using gravitational lensing, they came to realize the distribution was so strange that there seemed to be some whole other matter, which researchers believed is signs of dark matter. Our technology in science is really good, and all of our computer simulations seem to show that without this extra dark matter, the universe just wouldn't form the way it would after the Big Bang. Galaxies would drift apart, nothing would be able to form properly. So without it, the universe just doesn't work, and with it, dark matter fixes everything. And most interestingly, our best model for the universe, considering all the cosmological parameters, just seems to fall apart when we don't include dark matter. The maths just fails. So it just seems like the best solution to accept that this dark matter exists after all this evidence and all the maths that just seems to support it. But could it be wrong? Could all these phenomena be explained without dark matter? Introducing modern Newtonian dynamics. This is a theory which states that our laws of physics should be modified based on these lower accelerations that are more abundant in greater galaxies. Now what this would then say is that at these lower accelerations, the force of gravity is significantly stronger than what was first predicted by Newton. This suddenly explains a lot of our phenomena, and most notably explains the Tully-Fisher relation, which holds for a great range of galaxies. This says that the luminosity of a galaxy is related to its rotation velocity. And guess what? Dark matter can't explain that. So, what's really out there? Dark matter, or have we just misunderstood the universe? Well, dark matter and modern Newtonian dynamics are both good theories, but they're not perfect. Neither have been objectively proven, and yet there's still a lot of evidence for both. What can we take away from this? Well, the universe is still very much unknown. There's so much to learn. So, keep questioning, keep wondering, and keep putting your mind on the matter.